All right, so what is the Pythagorean theorem? A squared plus b squared equals c squared. Excellent. The x-axis is which trig? Cosine. Which means the y is sine. And in a unit circle, the radius is 1. We're going to apply all this. So you have an axis in your top box of your notes. Okay, so I'm going to draw a right triangle. Okay, this axis is worth what? The x, it's cosine. This one is sine. And the radius is 1. Great. What can I label this? It's moving in the direction of the y-axis, so I can label it y is what? Thank you, sine. Okay. So now let's apply this to the Pythagorean theorem. We have a squared plus b squared equals c squared. You are now in the middle box. The big, long middle box, okay? All right, so a is what? Cosine. So we have cosine squared x plus sine squared x equals 1 squared. Okay? 1 squared is simply 1. So I'm going to erase the little 2 and we're done. This is one of your trig identities. I can take this equation and come up with 2 others, easily manipulating it. Just so you know, this is the only one that they would give you on your formula sheet. Okay, so let's manipulate it. Okay, if I want cosine by itself, that is equal to 1 minus sine squared x. If I want sine squared by itself, 1 minus cosine squared x. And these should be familiar. You should have done this last year in Algebra 2. Okay? So those are the first 3 of 9. 9. Okay, so moving on. Think about tan. We can write tan other ways. What is another way we can write tan? Excellent. Sine over cosine. Okay, what's another way? Who's tangent's partner in crime? Cotangent. So tangent is the reciprocal of cotangent. So 1 over cotangent would give you tangent. Okay? 1 over secant would give me cosine. 1 over cosecant would give me sine. So those are some other pieces of trig identity. All right. Going back to the original equation that we did a couple minutes ago, I want you to divide each of these by sine squared. No, this is the bottom box. Doesn't matter. There's 2 boxes at the bottom. Pick one of them. All right, what's sine squared divided by sine squared? 1. What is cosine squared divided by sine squared? Cotangent squared. Well, you just told me a minute ago that sine over cosine was tangent, so if I do the reciprocal, it is cotangent. And what is 1 over sine squared? This means the reciprocal of sine. What's the reciprocal of sine? Cosecant. Okay? You now have come up with equation number 4. Omar, how did I get which piece? Okay, what is sine over cosine? Sine over cosine is tangent. So if I flip them or do the reciprocal of tangent is cotangent. Okay? All right, so now, just like earlier, I'm going to manipulate this to get two more equations. Okay, so if I get 1 by itself, that is cosecant squared. If I get 1 by itself, that's cosecant squared minus cotangent squared. I believe this is the one they give you on the formula sheet, not the blue one. Okay? And let's manipulate. Let's get cotangent squared by itself. That's going to be cosecant squared x, what? Minus 1. You now have 6 of the 9 major trig identities. Okay, let's continue. So I divided everything by sine. What do you think I'm going to do this time? Divide by cosine. Great. So I'm going to divide each of these by cosine squared. All right, so what's sine squared over cosine squared? Tangent. What's cosine over cosine? What's 1 over cosine? What's the reciprocal of cosine? Secant. Now, I had a very good question. Sine to the negative 1 is not cosecant. This is inverse, not reciprocal. When I'm asking for sine negative 1, that means I've given you a ratio and I'm asking for the angle measure. It is not reciprocal. If you wanted to graph cosecant, you would do 1 over sine x, y equals. That's how you would graph it. Okay? All right. Let's manipulate this equation here. I want tangent by itself. So secant squared x, what? Minus 1. Okay, let's manipulate it one more time. 1 is equal to secant squared x, what? Minus tangent squared x. You have now developed all 9 of the key trig identities. Three of the 9 will be given to you. The manipulations will not be. Yes, sir. Does it matter if, say it again, if you wrote tan minus secant? Yes, it does matter. Think of it this way. Is 7 minus 3 the same as 3 minus 7? No. Okay, so if I want 1 by itself, think about it algebraically. If I want it by itself, I have to subtract tan. Okay? Good question. All right, moving on. Okay. All right, so when I see this, what would I do? I heard it, distribute. So let's go ahead and do that. Tangent, yes. Tangent squared x. Now, what do you know about tangent and cotangent? They're reciprocals. When I multiply two reciprocals, what do I always get? 1. If you do a half times 2, those are reciprocals, right? What do you get? 1. So if I do tangent times cotangent, I'm going to get 1. If I do cosine times secant, 1. Sine times cosecant, 1. You got it. Now, please look at your paper. Is this one of the ones we developed? Yes, tangent squared x plus 1 is the same as secant squared x. So most of these will get dwindled down to a single trig or a single number. There's a couple that will not. Secant squared x. It's one of the identities. Yes, sir? Yep, that's the final answer. Yes, sir? Look at your paper, right? There's lots of them. I see tangent squared plus 1 equals secant squared. Divide first equation by cosine squared x. You see that? On your half sheet? Okay? Plus, if you go back, the first equation we wrote was tangent squared plus 1 equals secant squared. Okay. All right, next one. When I add two fractions, I need a common denominator. So the fastest common denominator is to multiply denominator by denominator, yes? Okay, so this first fraction, cosine, is missing what? 1 plus sine x. And then over here, cosine is missing 1 minus sine x. Now, what is 1 plus sine x times 1 plus sine x? Think of it this way. If I did 1 plus x times 1 minus x, what is it? 1, excellent. 1 minus sine squared x. It's the product of differences. All right. That's from Algebra 1, the product of differences. Ask your question. How did I get what part? The top part. Okay, if I have 1 over 2 plus 1 over 3, my common denominator is going to be 6. So I'm going to multiply the top by 3, this one by... Okay. All right, so now I'm going to... Sorry, I scrolled too far. Now I'm going to distribute. Let me move this out of the way. I get cosine x plus cosine x sine x plus, distribute again, cosine x minus cosine x sine x. And on the bottom, 1 minus sine squared x. What do you notice about the numerator? This cancels this. Shh. What is 1 cosine plus 1 cosine? No. 1x plus 1x, not squared. 2. 2 cosine x. And please use your cheat sheet. 1 minus cosine squared x is 1 minus sine squared cosine squared x. Now, please remember, okay, this means the same as this, yes? You don't have to write this out. I'm doing why it works. This means the same as this, yes? So I can cancel a cosine. So it's 2 over cosine. Now hold on. 2 over cosine x, or if cosine is in the denominator, that means I want the reciprocal. What's the reciprocal of cosine? 2 secant x is also correct. It's 2 over cosine x or 2 secant x. Steven. Okay, so the very first trig identity that we worked with is this. When I manipulate it, cosine squared equals 1 minus sine squared x. So I replace it with cosine. Ultimately, you want all the pieces to be the same trig. I did. Either one of these. Catherine. When I made the common denominator, this times this, it's the product of differences. You had to FOIL, but this is one that you should know the shortcut to from Algebra 1, okay? All right, moving on. Problem number 3. Okay. So the first thing I always do is look and see if it's one of the trig identities. If you see a 1, typically it's one of the trig identities, okay? So, does this look like any of the trig identities? Yes, it looks very similar to it looks like this one, except for this side is flipped. So when you flip, what is that in math? Reciprocal. It's a reflection. So I'm really going to replace this with negative cotangent because it's a reflection, right? I went boom, boom, boom. I multiplied all of them by -1, okay? All right, over cosecant squared. Now, rule 1, if it's one of the identities, swap it out. The next thing I do is I typically write things in all cosine or sine. Okay, you want it back to that basic trig. The basic trig is cosine, sine, and tangent, but really cosine and sine. So, how can I rewrite this using sines and cosine? Negative cosine squared x over sine squared x divided by, what is this using sine or cosine? It's the reciprocal of what? Sine. So 1 over sine squared x. Everyone with me now? First line, second line. That is so that you could understand why this was negative cotangent. Okay. Now, this is the same as why did I do that? Why did I go from this to this? Division is multiplying by the reciprocal. Cancel, and I'm left with negative cosine squared x. Problem done. Because over 1 doesn't matter, correct? Okay, I would like you to try number 4. Look for a trig. If none exists, you want to rewrite everything using cosines and sines. All right, so let's look at what you did with number 4. Okay, so there's definitely an easier way to do this one. All right, so I'm going to do, again, this is not an identity because it doesn't have the squared. So I'm going to rewrite everything using basic trig. Okay, there's another way to do it, but you'll see at the end. Okay, everyone good with that? Okay, so first thing, is it a trig identity? Nope. Rewrite it using the 3 basic trigs. Okay? I'm going to put this over 1. I have 2 fractions, therefore I need a common denominator. What's my common denominator? Tangent. Okay, so I'm going to multiply this by 1. I'm going to multiply this by tangent x because that's what's missing. Some people think of it as cross multiply. That's fine. So now it is 1 plus tangent squared x. What do you know about 1 plus tangent squared x? Secant squared x over tan x. Again, there was another way to do this problem, but at the end we should all simplify to the same. Now, this is not basic trig, so let's rewrite it using basic trig. Okay? Now let's rewrite both of them using only sines and cosines. So this becomes 1 over cosine squared x divided by, what is tangent using sines and cosines? Sine x over cosine x. Notice there's no square because this is a plane tangent. Okay, when you divide, you really do what? Multiply by the reciprocal. Okay, so now this cancels this, and it only gets rid of one of the cosines, right? Cosine squared is cosine times cosine. So I canceled one here, canceled one here. Yes? All right. Now, I have 1 over cosine x sine x. Okay? Or, when it's multiplication, you can split it up. So you can split it into 1 over cosine times 1 over sine, which is secant x cosecant x. I would prefer this. This is okay. No, you either want this or this because this is a little expanded. Okay? Question? There's nothing else I can do with cosine and sine. When it is back to a basic trig, there's nothing more you can do. So I changed it only because I don't like leaving my answers as fractions. Okay? You could, yes. And you will see. So this is stage 1. Stage 1 is simplifying. Eventually, it will do something like equals. So you have to prove it. So you have to manipulate one side to look like the other. Okay? So that's why right now I'm accepting multiple answers. And then when it gets to solving, there's only going to be one. I need to move ahead. I'm sorry? There's tons of different ways. I could have started, I'll just show you the beginning part. I could have started with cosine over sine plus sine over cosine. You still need to get a common denominator. So then you get cosine squared x plus sine squared x over sine x times cosine x. What's cosine squared plus sine squared? It's 1. Same thing, right? And 1 over sine is cosecant, 1 over cosine is secant. I get the same answer. Okay? All right. Okay, go ahead and try this one, please. Okay, in this particular one, I'm going to go ahead and rewrite those using sine and cosine. So sine x cosine x equals, I heard somebody say 1 over cosine x plus 1 over sine x. When I distribute to this, what cancels? cosine. So I'm left with sine x plus cosine x. These are basic trig. This is not an identity because it's not squared. Therefore, the problem is done. You got the same answer? Okay. All right. Let me show you one more quickly. You can't. This is not an identity and it's basic trig. Time out. Okay, in this one, I'm going to rewrite everything using basic trig. So I have cosine x over sine x divided by 1 over sine x and then times cosine x. Okay? So then that gives me cosine x over sine x multiplied by the reciprocal, sine squared x over cosine squared x. Remember that this gave me this gave me the cosine when I multiply. So then this cancels one of these, this cancels one of these, leaving me with sine over cosine, which is tangent x. Quick review. Okay, if I gave you 1 minus cosine squared x and asked you to factor it, think of it as 1 plus, undo that, 1 minus x squared. Okay, that's the product of differences. So we're going to do 1 plus x, 1 minus x. So in this particular case, it would be 1 plus cosine x times 1 minus cosine x.